Okay, so in the second part of class, we talked about separable equations. Now, any first order equation has the following form, linear or nonlinear. And we like this form because if m somehow only depends on x and n only depends on y, then I have a nice method to actually find the solution, right? So I'm going to let hm be such that if I differentiate h of m, I get m of x, and similarly for n, hn prime of x is equal to n of x, or n of y, sorry. Okay, so having this information is useful because then my differential equation is really equivalent to the following. Okay, and you can check this by just applying the chain rule here. Okay, now this is nice because then I can just integrate from x0 to x, m of s ds, plus the integral from x0 to x, hn of okay. And so we end up with, you realize that if the antiderivative is h of m, we end up with hm of x minus hm of x0 plus hm of y of x minus oh sorry, this is not m, but rather hn of y of x0 is equal to 0, okay? Or I can write it as hm of x plus hn of y is equal to m of x0 plus hn of y of x0, okay? This can be a constant, right? So in general, this is our solution. Now this is an implicit solution because y is not necessarily of the form phi of x, right? But nevertheless, we can check that this is indeed a solution to our differential equation. Okay, so we actually ended up again with the solution hn of y is equal to some constant. Now, let's check that this actually satisfies our differential equation, right, for NEC. And to do that, we can just take the derivative with respect to x. We end up with m of x, dx is just 1, plus the derivative of h with respect to y would be n of y dy dx is equal to 0. So notice that it does satisfy our initial condition. Again, this is implicitly because you cannot write this as y of x as some function of x, right? And we'll talk a little bit in class about what the difference between this implicit solution and a general solution is. But for now, let's look at an example. Okay, well, let's consider the following example. Let me call this star. The first thing to do is we want to write it in the form that we saw earlier. Of course, we want to group all the independent variables and the dependent variables together. So let me write it as 1 plus x cubed is equal to 0, okay? So notice that this is n and this is m. So step 2, we find antiderivatives. In particular, we really want initially the antiderivative of n, right? So hn of y is going to be 1/2 y squared. And then we'll later out figure what the antiderivative of m is, which is a little bit more complicated, right? But the key is that now star is equivalent to minus x squared over 1 plus x cubed plus d dx of 1/2 y squared is equal to 0, right? So now we integrate and we end up with x0 to x minus s squared over 1 plus s cubed ds plus the integral from x0 to x of d dx of 1/2 y squared is equal to 0, okay? So this is 1 and this is 2. So let's figure out what 1 is. Here we have to do a change of variables. So I'm going to let u be 1 plus s cubed. du is 3s squared ds, and so we end up with minus 1/3 1 over u du, and the limits of integration are going to be 1 x0 cubed to 1 plus x cubed, and I actually can solve that. This is going to be natural log of 1 plus x cubed plus 1/3 natural log of 1 plus x not cubed, okay? So you have to remember this sort of substitution method. And 2 is actually just simply 1/2. Sorry, this is 2. Let me delete that. Okay, so 2 is nothing more than 1/2 y of x. Just y of x squared minus 1/2 y of x0 squared. So putting it all together, I have okay, so putting everything together then gives me 1/2 y squared of x minus 1/3 natural log of 1 plus x cubed is equal to 1/2 y squared of x naught. This is a naught minus 1/3 natural log of 1 plus x naught cubed, okay? And I can call this a constant, right? And so we end up with the solution 1/2 y squared of x minus 1/3 natural log of 1 plus x cubed is equal to a constant. And let's check that this is indeed a solution by taking the time derivative, not the time derivative, the x derivative of this guy. this is a constant, right? So chain rule tells me that this is y prime minus 1/3. The derivative of the natural log of 1 over x squared is 1 over 1 plus x cubed, because the constant can be anything. I can get rid of those absolute values. Times the derivative of the inside, which is 3x squared, is equal to 0, right? Which indeed is y prime minus x squared over 1 plus x cubed is equal to 0. All right, so we in fact found our solution, even though it's not in an explicit form. Nevertheless, many times you can actually graph the integral curves, and we'll look at a quick example on Thursday.